Okay. Good afternoon. Am I audible to you all? क्या आप मुझे सुन पा रहे हो? Hello, mic check 1 2 3. I'll run the poll. Okay. Just reply the poll. Reply नहीं. Mark the poll. Okay. Okay. Nice. How you all are? What is going on? पेपर है साथ में. Hi Alish. Good afternoon on YouTube. I am very nice. So we'll discuss the questions. Okay. Some of the important questions I have selected. Right. First, we will start with JE questions. Advanced वाला paper जो था, we'll start with JE, and then we will start with okay Hemant. Then we will start with NEET questions. Okay, right? So I'm ending this poll. How many of you think will get marks greater than the previous one? I think this paper was little bit simple, ना? ये paper थोड़ा simple आया था in comparison to the previous one. I am talking about JE one. How many people are of you here from JE? Tick mark करो. Tick yourself. How many of you are from JE Advanced? No one? Good afternoon, Pramod. Good afternoon, Nandini. तुम में से कितने लोग JE से हो? Means are willing to give JE exam जब भी होता है. Tick on yourself. Okay, Bhumik. Typing tick. Oh my God. You don't know what is tick? There is one option called, I think emoticons is there, na? One option. You can go there and you can just click on the tick button. JE people are less. JE people कम है. अच्छा, untick yourself JE वाले. Others are NEET. All are NEET. NEET वाले tick. Oh, NEET are there mostly. Oh my God. चलो तो फिर एक काम करेंगे. We'll do JE quickly. Then we will go to NEET, है ना? Okay. Untick yourself. Untick yourself. Okay, so we'll start with fourth question in the question paper, right? NEET का question paper fourth start करेंगे. I'll just close my video so that you can see the whole screen. Okay, so this was a good question, right? ये किसी को समझ में भी नहीं आया होगा question में है क्या, what is there in the question it is asking, right? So a very long cylindrical galaxy मतलब there is a what do we call hypothetical galaxy, right? And this galaxy is cylindrical. Okay, red color nahi, we'll take some other color. This galaxy is cylinder. Okay, it is having a length of L, right? And it is made up of uniformly distributed mass and has a radius of R. Okay, so this galaxy is basically having radius of R. Okay, A star outside the galaxy is orbiting the galaxy. So there is a star. Star ऐसा होता है? ऐसा होता है? No, it appears like this because we are very far distant ना. Have you heard Doppler effect? I think there was one video, है ना? उसको देखना, so you will get the reason. ऐसा दिखता है, but actually it is not like this. It is spherical mostly, right? So there is a star outside the galaxy and is orbiting around the galaxy in a plane perpendicular to the axis of the galaxy. So this is the plane which is perpendicular to the galaxy. मतलब ऐसा लेके चल लो. Okay, this is the plane which is perpendicular. I'm taking an example. Okay, plane is infinite here. So this is the plane perpendicular to the axis of galaxy. The galaxy axis of galaxy is this one. Okay, so this star is basically rotating like this, like this, like this. Okay. Now, if time period of the star is t, time period is given, and the distance from the galaxy axis is r. So distance from the galaxy axis of the star is r, right? then we have to find the relation between time and this r. Okay. Acha. So when this star is rotating, agar ye star rotate kar raha hai, so it will be in the field of this cylinder, right? Because it is made up of a uniform distributed mass. एक mass से बना हुआ है, right? There may be some planets and all inside this. So there are uniformly distributed masses inside this. So it will attract this star with some gravitational force, correct? Which is F centripetal. इस force से इसको attract करेगा like this. And it is rotating. This is rotating. So it will have an outside force. Sorry, this is not centripetal, this is gravitational. Okay, gravitation se attract karega, and there will be some centripetal force which will be outside, which is kya hota tha, m omega square r, where m is the mass of the star, omega is the angular velocity, and r is the distance from the cylinder, right? And if it is rotating, so it is not having some ups and downs that completely it is rotating. We are assuming that it is rotating in a circular motion. So this Fg will be equal to m omega square r, right? Now the question arises, how we'll find this Fg? Okay, because it is not a point mass. This galaxy is not a point mass. It is a cylindrical mass. So there will be something that we should do here, okay, to calculate the gravitational force between this. Okay, so I'll just think a little bit. Can I find the field निकाल सकते हैं? इसका field gravitational field निकाल सकते हैं, right? By using Gauss law. Gauss law का use करके निकाल सकते हैं. देखो यहाँ पे I am using Gauss law in gravity. Gravitational में अपन Gauss law use करेंगे. There is one more solution in your solution answer, but that I think is little bit confusing, है ना? अपन इस तरीके से करते हैं. We are trying to do by Gauss law, right? So we'll assume these masses as charges. Okay. So Gauss law, what it tells, E dot dA is equal to Q enclosed by epsilon naught. You know you know this thing, na? Potential is equal to Q enclosed by epsilon naught. The flux, sorry, not potential. Flux is equal to charge enclosed by epsilon naught. Tell me in the chat, you know these things? ये तुम लोगों को आता है? Reply to me yes or no. Reply. Don't sleep. Flux. Gauss law आता है? Flux is equal to Q enclosed by epsilon naught. Yes. Okay. So this thing we will use, right? देखो now you see We will find electric field from here, right? Electric field कैसे आ जाएगा? So electric field is DA is the small section area, right? So I am taking a small section, E dot 2 pi r into L. Okay, so this will be the area when we will integrate it. Lagging, is it lagging? No, it is not lagging. Lag हो रहा है. Is it lagging? Is my voice lagging? No, na? Tejas, your internet is lagging. Refresh करो उसको. Refresh your internet connection. Flight mode on करो, off करो. Do that thing. Okay? It is not lagging. Okay. Chalo, let's come back. So 2 pi RL is the area, right? And this area is equal to the charge enclosed by epsilon naught. Okay. So how much is the charge? Charge means or mass we can call. Okay. Lambda यहाँ पे क्या दिया हुआ है? Okay, no problem. Let's take lambda as the uniform distributed mass here. Okay. So lambda into L divided by epsilon naught. Lambda is the mass density we can call. Charge density होता था, just like that mass density. Okay. चलो. So यहाँ से we will get the electric field. LL cancel होता है. So electric field is equal to electric field, or here we are trying to find gravitational field. We will convert it into gravitational field. Okay. For relation only we are using E. Lambda by 2 pi epsilon naught R. It is for change, sir. Then how is its mass? Which change? No, see here what we are basically doing. Arey, dekho, what we are basically doing is the gravitational potential due to cylindrical mass distribution easily can be found when we compare it with electric field due to cylindrical charge distribution. Remember this thing. It will be difficult when you will find gravitational potential due to cylinder. थोड़ा सा difficult जाता है. We are more familiar with Gauss law, है ना? So वो use करके we are just trying to use that thing. वो use करके then we are trying to find. Are you getting it? The solution, I think if you are not understanding this one, you can refer to the notes वो जो दिया है, which is given in your group. You can do that one. That is direct. But I'm trying to make you understand different thing. That's why I took this question. है ना? Try to compare it with charge. Mass को यहाँ पे हम क्या कर रहे हैं? What we are doing to the mass? Mass is compared with charge. Okay, that thing we are doing. An electric field with gravitational field, like that we are trying to do. चलो, so अच्छा इसको क्या लिख सकते हैं? If I write it more clearly, E is equal to 2g lambda by r. Okay, so what I am doing here is gravitational field को I am taking 1 by 4 pi epsilon naught as g. Okay, this constant, वो constant उसमें भी आता है, electrical field में भी, right? Okay, now centripetal force. Centripetal force क्या होगा? Force is equal to, we know it is m into gravitational field or E, which we have found here, right? Charge into E होता है force. So here mass we are assuming in place of charge, so mass into E. So mass into E is m into 2g lambda by r. Okay, and which is equal to centripetal force. Centripetal force was m omega square r. Okay, so I'm writing it m omega square r, right? mm उड़ गया. So from here what relation we will get is omega we will find ना. Omega is equal to r नीचे आएगा under root of 2g lambda by r square. So it will be under root of 2g lambda by r square. Off your camera, Oppo A15. अपना कैमरा बंद करो. Okay. R square का under root is r. Okay. So here it will be r. Okay. Now we have to find relation with time, not with omega, but we know omega is equal to 2 pi by t, right? So in place of t, what can I put? T is equal to 2 pi by omega. नहीं ऐसा क्यों लिखना है? ओमेगा की जगह रखते हैं. We'll write in place of omega 2 pi by t is equal to under root 2g lambda by r. So from here I can directly say t is directly proportional to r. Either you take reciprocal. बोलो ये चीज समझ में आया? Have you understood this thing? Option 3 is correct. Have you understood this thing? है ना? So this is a different way of doing, and this is little bit more faster. ये जल्दी कर सकते हो if you know the if you click it in your mind. Okay, so it clicked in my mind, that's why I explained you. Repeat, sir. देखो, I'll repeat it quickly. Question is asking, there is a long cylindrical galaxy, right? It is containing masses. इसमें बहुत सारे masses. There are so many masses inside it, but it is uniformly distributed, right? Now there is one star which is at a distance of r. Okay, this star is rotating around it just like earth is rotating around sun. Okay, so वैसे ही this star is rotating around this galaxy. Okay, rotate हो रहा है. Now it will rotate only when the gravitational pull of this galaxy, because it is having some masses, so gravitational pull of this galaxy will be equal to the centripetal force on this star due to its circulation. So Fg will be equal to m omega square r. Now omega we can write easily 2 pi by t, then we will get the relation. But the problem is we have to find the gravitational force. But gravitational force we cannot find directly because it is not a point mass. It is a mass which is very, very big. Okay. And if we calculate with using gravitational laws, then it can be done, but it may be little long. So I done it by what mass in place of charge I am doing. Okay, so I'm assuming mass as charge. Okay, and the gravitational field as electric field, then I'm finding. So due to cylinder, I use here Gauss law. Gauss law says that flux is equal to the electric field in a closed area. Okay, integral of electric field into closed area is equal to q by epsilon naught, the enclosed charge inside it divided by epsilon naught. Then I put in place of area 2 pi rl, which is the area of the galaxy, and then I put the q enclosed, charge enclosed, because I am assuming charge as mass. So q enclosed will be equal to charge density or mass density into length. Okay. Next, I'm not taking area. I'm assuming this density to be already areatical, right? Disk I'm taking small disks, right? And I'm integrating it to L, to 2 pi RL. तो उससे पूरा area आ जाएगा, पूरा volume आ जाएगा, right? Because when we integrate this area, na, we get volume. That's why I've directly written here volume in place of integrating it. Volume of a cylinder is 2 pi RL, right? Which is equal to lambda L by epsilon naught. Solve kiya, then we got this electric field or gravitational field. Electric field we are taking as gravitational field. I'm comparing both things now. Now force we have to find. Force is mass into the field. Okay, mass into field I have written. Then I equated it with centripetal force, because they will be equal, then only it will do circular motion. So omega aa jayega. When we get omega, we can easily find the relation between time and the radius, the distance between the star and the galaxy. Okay, just reciprocate it and you will get T directly proportional to R. Is this thing clear? If we equate centripetal force with gravitational force, then also same relation. No, sir. That only we are using to solve this thing. That is the main thing. Okay. चलो, next we will go to the other question. This one. Okay, this is another good question. A point charge q is placed at the center of the surface, okay, of a hemispherical surface as shown in the figure. So there is a point charge, this q. Okay, the electric flux linked with the curved surface, hemispherical surface, is nearest to, right? In this question, one assumption we have to take, this charge is inside of this hemispherical ball. Okay, that assumption we have to take. So it is little bit inside. So now the total flux, how much will be the total flux here? Which is the flux passing through this surface, okay, and the flux passing through this surface, the hemispherical surface. Okay, so it is asking here the electric flux linked with the curved one. So we have to find the electric flux which is linked with the curved one, right? So curved one से निकालना है. अच्छा, I think you know this formula already of solid angle. अच्छा, अगर solid angle ऐसा है, this is the solid angle, then there is one formula ना to find the flux if charge is there. Q is equal to, sorry, flux, not charge. Flux is equal to Q by 2 epsilon naught 1 minus cos theta, which is theta is the angle, right? Sorry, theta is the half angle. This one. ये आता है ना, ये पता है? Okay, so what we will do is, what the basic idea here is, find the total flux. Total flux will be how much? By Gauss law, Q by epsilon naught. Simple. Total flux through this hemisphere is, basically it is a closed surface, huh? Remember this thing. Some people will think it is open from the base, from this disc part. It is a closed hemispherical ball. You take one ball and put something on it, put some cardboard on it, and cut it according to the circle. That type of closed ball it is. Okay, so total flux will be by Gauss law, Q enclosed by epsilon naught. Q enclosed is Q by epsilon naught. Okay, that's why we have assumed this charge to be inside. That assumption we have to take. Now if we want to find the, okay, basically this is equal to flux from hemispherical surface plus flux from disc surface, we can call, name doesn't matter, you have to understand disc surface. Okay, so disc surface se aa jayega, then we will easily get this one, right? So flux from hemispherical surface is equal to total flux minus flux from disc. Okay, so total flux is how much? Q by epsilon naught minus the disc surface say flux kitna hoga? Flux will be equal to Q by 2 epsilon naught into 1 minus. Now we have to find the angle. Okay, angle निकालना है तो यहाँ पे जाएंगे. We'll go, I'll make the diagram here once more. Simple mathematics it is. Okay, इसमें क्या करेंगे फिर? Here is the charge just at the center. It is given in the question that it is at the center. We'll join this thing. We'll join this thing. Oh, ज़्यादा हो गया. Okay, we know the property na, diameter makes 90 degree. Now if I make a perpendicular, so these both are isosceles triangles, this will be half of 90, that is 45. Okay, so finally theta will be 45 here. So we'll write Q by epsilon naught 1 minus cos 45. When you open this bracket, you will get Q by epsilon naught, which will be cancelled by this one. So what will be remained? Q by epsilon naught into cos 45. Cos 45 is 1 by root 2. This will be your answer. Okay, I think it is clear, है ना? So this was the concept here. That's why I took this question. थोड़ा सा ये समझना जरूरी था. Next. Okay, this is also another very good question. Who have done this question correct? ये correct किस किसने किया है? Tell me in the chat. ये क्वेश्चन किस किसने सही किया है? Sir, for need, we will discuss need. Don't worry. Discuss करेंगे. Let's discuss some good IT questions. These are also very good concept making questions. Okay, Meghna. So you just try to understand these questions. तो need तो फिर बच्चा question है. Okay. Okay, राहुल का सही था. Nice. Chalo. So we'll take the feel of this question, right? A motor boat is to reach at a point 60° upstream. That means there is a motor boat. It is in the water. Okay, which is flowing at some rate. So let's make that diagram. This is the river. Water is flowing upstream. Let's say water is flowing like this. Okay, I'm not making in whole river because I need to do some calculations also. See, calculation diagram making. That's why. So a motor boat. Here is a motor boat. Okay, this is the motor boat. It has to reach at a point 60° upstream. I think you know what is upstream and downstream. If you flow with the flow of river, then it is called downstream. And if you flow opposite to the river, that means you are climbing the river, na, basically. That's why it is called upstream. So upstream ja raha hai 60°, 60° upstream on the other side of the river. Okay. So 60° upstream means, okay, 60° upstream means like this, 60°. Okay. So here this motorboat want to reach. Okay. So always assume the angle with positive x-axis. That is the basic rule if it is not given in the question, right? And velocity, river flowing with a velocity of 5. So this velocity of river is 5 meters per second. Velocity of motor boat with respect to water. Okay, velocity of motor boat is also given 5√3, right? The driver should steer the boat at an angle of. Dekho, now the feel is very simple. River is flowing left. You want to go to this point, but if you start directly going towards this point, the river water will tell you, okay, I will not allow you to go there. I will push you like this when you will travel because river is flowing in this direction. I will push you like this and I will land you somewhere here. And that will not be 60°. This is the idea of river. Okay. This is the thinking of river. And so what we have to think more? We have to think more, more than river. Okay, river, you will push us, na? So what we will do? We will not go in this direction. We will go a little bit here. हम ऐसे जाएंगे. So when you will push us, na, we will come to our path back here. Okay. So we will go in this direction. You push, again we will come here. Okay. So we will go like this. Right. So let's say this angle is theta. Okay. Total angle was 60. And this total angle is 60. This angle is theta. Okay, so we have to go in theta direction. This is the basic feel or the basic fundamental of this question. Okay, now let's come to options. Okay, so first in this type of questions, what you have to do is, first of all, you check the options. कहीं option में ऐसा तो नहीं है कि all options are very senseless. Only one option is making sense. So you have to check that first. Okay, first option is telling 45° with respect to the line of destination from starting point. Try to understand this thing. 45° with respect to the line of destination from starting point. That means line of destination from starting point is, this is the destination. Okay, this is the starting point. This is the starting point. This is the destination. And this is the line joining between them. Okay. Now 45° with respect to the line joining line of destination from starting point. मतलब इस line के respect में it should be 45°. Okay, it is not telling whether it is left side or right side. Okay, chalo next one. 30° with respect to normal to the bank. So this is called bank. Okay, and 30 degree with respect to normal to the bank means bank के 30 degree normal, sorry, with respect to the normal to the bank. अच्छा, इस बैंक का जो normal है, this is the normal direction. I'll tell you which is the normal direction. This is the normal direction. So इसके respect में 30 degrees. Okay, this it is telling. Third option is 150 degree with respect to the stream direction. Stream का direction is this one, and इसके respect में 150 degrees. Okay. Next, 45 degree with upstream. Upstream means this one, इसके respect में 45 degrees, like this. Okay, these are the four options. Okay, so the four options make sense. Okay, there is no senseless option here. So we'll check. Okay, now how to proceed to this question? So basically, we will proceed in a very simple way. The velocity is 5√3. I'll make another diagram here. 5√3, 60 degrees. So the component will be 5√3 cos 60. Cos 60 is 1/2. Okay, right? Acha, this component doesn't make any sense. Why? Because theta का भी एक component निकालना पड़ेगा. Then we have to add those components, है ना? So that will make sense, right? Sorry, cos 60 is not 1/2. I'll write it once more. Okay, चलो. So 5√3 ऐसे जा रहा है. The velocity will be somewhat vertical, somewhat horizontal. Okay, vertical velocity कितना होगा? Let it is moving with an angle of theta here. Theta पे चल रहा है. हाँ, ऐसा जा नहीं सकता है. So we are not taking this one. 5√3 ऐसा जाएगा. It will go like this. So it will be 5√3 cos theta, and it will be 5√3 sin theta. Okay, this theta we have to find. In which angle should it go? Okay, chalo. Now the river is flowing 5 backwards. Okay, so this horizontal component will be subtracted, right? That we will subtract. So इसको subtract करते हैं, and then we will take the net velocity. Okay, so net velocity के लिए I'm writing it here. 5 minus 5√3 cos theta. Okay, this is in the x direction. So I'll write I cap plus 5√3 sin theta in jth direction, upside direction. So I will write it as j. Okay, I hope this is clear. Horizontal velocity plus vertical velocity. This will be the net velocity. Okay. Next, we want to find the angle. Okay. So angle के लिए क्या करेंगे? Tan theta. Tan theta will be equal to 5√3 sin theta divided by 5 minus 5√3 cos theta, which will be equal to minus of √3. Okay, so when you solve this thing, you will finally get theta equals to 30. That means ये 30 आ जाएगा. Okay, that solving is your part. You can see in the solution it is given, right? So basically I want to teach the concept in this question, right? 30 आ जाएगा ये. When you get 30, that means यहाँ से angle होगा 150. Okay, so there was one option, which is option third, 150 with respect to stream direction, which is correct, right? Chalo, so much time is elapsed in this question. Okay, this question we will do quickly. जल्दी से जल्दी करेंगे. This question I think is not needed much because only one small concept is there which I need to teach you in this one. Basically, this is a pulley, you can assume. Okay, these masses are attached to some strings and they can slide. If M goes like this, then B comes like this. Okay, this is the basic idea. So it is telling two particles A and B, each of mass M, are interconnected by an inextensible string. Inextensible means it cannot be extended. extended string such that particle B hangs below the table as shown in the figure and particle A is on the rough surface. Rough rotating disk at a distance r from the axis, right? If the angular speed of the disk and the block, is given as omega, the frictional force developed at the interface of the particle and the disk is equal to. Now this is very simple idea question. See, I'll make this diagram quickly. It is hanging down, mass, p particle, this particle is here, okay. Okay, so it is rotating, ऐसे घूम रहा है, right? Now, if this particle is rotating, it will have a centripetal force outside. Okay, ये particle का centripetal force होगा बाहर की तरफ, right? And it will have a force downside also, which is mg. So it will have a tension of mg. Okay. So this tension will be same. एक string में एक ही tension रहता है. There is one string. There is same tension in a single string, right? So T will be here. This is here. This is here, right? And friction. Friction. If let's say this block is moving towards left. If this block is moving towards left, so this frictional force will be on the right side, which is mg mu. Mg mu. Mu is the frictional coefficient. Okay. So here in the question, we have to find the friction force developed at the interface. So we can directly write this as F because we have to find this F only. Now we can equate very simple. T okay, can you is the if you people can hear me, just tell me in the chat. Some network issue. Hello, can you people hear me? Okay. Chalo. I think there was some network issue. Okay, fine. Chalo, so what? Where were we? Okay, so tension. Off your videos, Sushma. Off your video. Video off karo. Sushma, off your video. Yeah. Okay, so tension will be equal to m omega square r, which is the centripetal force, right? Plus frictional force. Okay. So from here we will get what we have to find? Frictional force. Na? So frictional force will be T minus m omega square r. T is mg minus m omega square r. ओमेगा का वैल्यू रखेंगे, m कॉमन ले लेते हैं, g माइनस ओमेगा का वैल्यू इज अंडर रूट g बाय r होल स्क्वायर इंटू r. सो ये अरे ये तो कैंसिल हो गया, g स्क्वायर बाय r, सॉरी g बाय r, दिस इज g बाय r माइनस g बाय r इंटू r m. ओके, r कैंसिल, g कैंसिल, वी गॉट 0. अच्छा, आई हैव टुक दिस क्वेश्चन फॉर दिस आंसर. ये क्वेश्चन मैंने इसलिए लिया है ड्यू टू दिस आंसर. इफ वी आर गेटिंग 0 as the answer, that means this system is stable. This block is not going down. This block is not moving left. Our assumption was wrong. Okay. So this was the basic idea of this question. Chalo. Okay. This question is simple. We will discuss this question very quickly. Then we'll go to neat questions. Right. So a source of constant potential difference. Okay. This question, see, the numerical answer is given in the solutions. I'll tell you the trick, or I'll tell you the mind that you can make for this question so that you will get answer very quickly in the exams. First of all, let's make the diagram. Okay, this answer can be obtained by feeling. फील करने से आंसर आएगा। कैसे? सोर्स ऑफ कांस्टेंट पोटेंशियल डिफरेंस इज कनेक्टेड अक्रॉस ए कंडक्टर, दिस इज अ कंडक्टर, राइट? या नेहा, आर यू आस्किंग एनी क्वेश्चन? टाइप इन द चैट इफ यू हैव एनी क्वेश्चन। ओके, सो दिस इज अ कंडक्टर, ये कंडक्टर है, राइट? फ्रॉम दिस कंडक्टर something is flowing, let's say electric field is flowing, okay, or the electrons are flowing. Because there is current, electrons will flow, so some section is taken from here and some section is taken from here. Of course the area A2 and A2 is less than A1. Okay, now always remember, एक कॉन्सेप्ट हमेशा याद रखना, ऑलवेज रिमेंबर, one current in one wire. Okay, so you will always have a single current in one wire. In one wire you cannot have two currents. Okay, series connection you have seen na, you attach how many resistances you want, but you will have a single current. In parallel the currents can be different, so there will be same current all through this wire. Okay, now सेम करंट का मतलब क्या होता है सर? सेम करंट मीन्स I is Q by T. That means here charges are electrons, let's say. So charges, electrons, the flow of electrons per unit time is same. Okay, let's say if from this surface, let's say there were 5 electrons flowing, 3, 4 and 5. Okay, so from this surface also 5 electrons will be flowing. Remember this thing. Okay, per unit time, let's say in 1 second. I think you got this idea. ये समझ में आया what I am trying to tell? 5 electrons from A1 and 5 electrons from A2. Same number of electrons will be flowing within the given time. अच्छा, difference कहाँ पे आया सर? The difference is the closeness of the electrons or the closeness of the charges. Here the density of charge is high charge density, right? And here the density is low. Charges are apart na, same charges, they will repel each other, so they will try to move as far as possible. Conductor के ऊपर रहता है ना charges, so low density of charges. Okay, ये चीज समझ में आया होगा, I hope. Okay, अब now let's see the options. Options में क्या बोला है? So in options it is telling electric field intensity at P मतलब this point, this is Q, at P is greater than the Q. Electrical field intensity. Electrical field intensity we can just assume just like of electric field density, right? So यहाँ पे electric field तो होगा, but it will be थोड़ा फैला हुआ होगा, right? It will be little bit exaggerated. Okay, here electric field will be there, but it will be very close. So the option is telling ulta, electric field at Q will be greater than electric field at P. By feeling I am telling, okay, calculation is there in the notes, in the answer sheets, right, which is provided to you. Okay, so first is true or false? First is false, I think. Okay, now let's come to the next one. दूसरे पे आते हैं. Rate of electrons crossing per unit area. Okay, so how many electrons are crossing per unit area is P at P is less than Q, right? So if I take per unit area, if I take this area, I am coloring it, see, so there are only 2 electrons. Okay, if I take the same area, let's say I am taking full area, so there are 5 electrons. So in which section the electrons flowing are more per unit area? That is A2 or Q, because the electron density is large there. So option 2 will be correct. Similarly, you can check for option 3 and option 4 also, right? So this was the basic explanation I want to give in this question, right? Okay. Now, how much time is left? So we'll proceed to NEET questions. Chalo, we'll go to NEET questions now. ये question बहुत simple है. This question is very simple ना. इसमें concept क्या है? This was the JEE question, okay, number 22. So concept was there are 3 blocks. I'll quickly explain it. There are 3 blocks connected by a string passing over a pulley. Coefficient of friction is given 0.6. Okay, so यहाँ पर friction coefficient is 0.6. Now the frictional force we have to find. Okay, so there will be 2 conditions. First condition is 6 kilogram wala box is moving. 6 kilogram wala box moving, and second condition is not moving. So let's check first, is it moving or not? Move ho bhi raha hai ki nahi? Okay, so how we'll check that? It is very simple. Just calculate the force of friction here. It is mg mu, mass is 6, 10, 0.6, 36 newtons. Okay, so this much friction force can be applied here. Friction itne se is block ko rok sakta hai. It can stop the block by this much force. Now let's check how much is the force these both blocks are applying. Okay, so this block will pull this string downside, and this block will pull this string this side. Net force will be force net on 6 kg due to 3 and 1 will be force of 3 minus force of 1. Of course, force of 3 will be more, na? That's why I've written like this. Towards 3 kg. Logic tells na it will be towards 3 kg. Okay, but we have to check, is it moving or not? This system is moving or not? So F3 is 30. I'm writing directly mg minus 10. It is 20 newtons. Oh my God. These blocks are applying a 20 Newton left side here. But here friction is present. Friction is telling, oh, I will not allow you to go. I have more power. I have more 36 newtons. Okay, so friction force will give 20 newtons from this 36 newtons. Okay, so frictional force will be 20 newtons here. And the system is not moving. This was the main concept here. Chalo, now let's move to NEET questions. Okay, this question may confuse you sometimes. So in this question, it is telling there are 2 vectors A and B that are inclined to each other at an angle theta. Okay, A vector, B vector, theta angle par hai. What 2? Acha, option 2. I know option 2 is correct. Explanation should be there, na? Dekho, suno. Now it is telling which of the following is the unit vector perpendicular to both A and B. So whenever we do cross product, na, do you know this thing? जब भी cross product करते हैं, the vector which is developed is perpendicular. Okay, let's say there is one vector A, there is one vector. Oh, just hold on. B here, right? दो vector है. Now this vector A and B, these are in same plane. Let's say they are in same plane. एक plane में रखा हुआ है. So when we cross multiply them, na, so there will be a vector developed which is just perpendicular to the vector of A and B. Okay. So these all vectors are having cross. So direction to all vectors are telling it is correct, right? But it is also telling which of the following is the unit vector. Unit vector kaun sa hoga? Tell us that. Okay, so I can see in the first option vector upon dot product, cross upon dot. No unit is there. Okay, cross upon dot, first wala I am writing it here. देखो, AB sin theta. A cross B is AB sin theta. You know these things, I have told you. in unit and dimension chapter when revision was there. And downside dot product, so AB cos theta. AB cancel, so it is tan theta. Tan theta is not necessarily that it will be 1. Depends on theta. First is wrong. Let's come to second one. Second one, देखो ऊपर यूनिट वेक्टर है and downside is this theta. So I'll write a cap or dot b cap. A cap b cap का magnitude is 1 into sin theta divided by sin theta. So magnitude of this is 1. This is also 1. So I'll write sin theta upon sin theta, cancel. So answer is 1. Similarly, you can do for this also and this also. इसका क्या हो जाएगा? This will be AB sin theta. No, this will not be AB sin theta. See here, pay attention. This is cap. Cap है इधर. Okay, and this is vector. Right? यहाँ पे cap है, यहाँ पे vector है. Right? So you can do similarly for these others also. Okay. So I took this question because I can tell you here the concept of ammeter and voltmeter. Those who don't know, read the question. Question पढ़ो. I'll give 10 seconds. Read the question. And tell me in the chat how ammeter is formed with the help of galvanometer. How ammeter is formed with the help of galvanometer. Sir, screen is not clear. Meghna, what you can do is just go on the settings. 3 dots will be there. Click on quality and click on advanced, and then you can click on 720 pixels. Okay, your video will be clear. Series connection of shunt resistance. Connection of shunt of high resistance with galvanometer in series by shunt resistance. Okay, not by shunt, by series resistance. Okay, shunt resistance नहीं लगता है. चलो, so I'll explain quickly first what is ammeter and voltmeter, how they are formed. Okay, then we will do this question. Galvanometer क्या होता है? Galvanometer is a device which contains some coil. Okay, when a small current is passed through that coil, due to magnetic field creation, it will have a needle and it will move accordingly. Okay, galvanometer में वो होता है, there is a coil and due to current it produces a magnetic field and then it moves that pointer. Okay, अब galvanometer तो है, but how we will use this as a ammeter and voltmeter. Let's first discuss about voltmeter के बारे में बात करते हैं पहले. Okay, the one thing you have to always remember, voltmeter is connected in parallel. Okay, voltmeter parallel में connect होता है, right? अच्छा, when we connect these devices ना, ammeter and voltmeter, you have to remember that these devices should not change the resistance of the circuit because they are testing devices ना. Basically they should not change the resistance and all. सिर्फ वो test करने के लिए लगा रहे हैं, right? So when we attach a voltmeter here, it should not change the current flowing in this circuit, right? Let's say I current is flowing, so little bit can go, very less. Let's say this is 1000 amperes, so 1 ampere can go here. Okay, 1000 ampere is so much large, huh? Okay, so 1 ampere can go here like this. Okay, so very less current go here. If less current should go here, that means this path should be made very high resistant. Current is intelligent, huh? This is intelligent. This will always find a path which is less resistive. जो path कम resistance वाला होता है, ये उससे pass होता है. Okay, so what you do? You make this voltmeter resistance very high. बहुत high बना दो इसका resistance. Then very less current will pass. All the current will pass through here. सारा current यहाँ से pass हो जाएगा, right? And this voltmeter will not affect the circuit. Okay, so for making this voltmeter very high resistance, galvanometer में we attach a series resistance here. Okay, right? Series resistance लगाते वो भी very high. Is this thing clear? Tell me in the chat. Once more. Okay. Once more you needed? अरे I told you ना. देखो, this is our circuit. ये हमारा circuit था. Normal circuit. There was an internal resistance. There was a battery. I want to measure the voltage across this R resistance. So I'll attach a voltmeter here. Now this voltmeter should not affect my current in the circuit. मेरे current को ये affect नहीं करना चाहिए, right? If it will affect the current, that means it is creating some problem. It is taking some power, right? So current को affect नहीं करना चाहिए. That means all current should pass from this resistance only. Now also, so very, very, very less should current pass through this one. If very less current will pass through this voltmeter, then it should be very high resistive. Very high resistive. Okay. For making it very high resistive, just attach, this is galvanometer, just attach a series resistance here, which is very high. Okay, so this resistance will be high, so current will be comfortable to pass from this low resistance. Okay? It will not pass from the voltmeter, so we will get the voltage also, and the current also is not disturbed, right? This is the basic idea. I think it is clear now. Don't go in the details. इस टाइम पे डिटेल में नहीं जाना. यू आर हैविंग एग्जाम्स ना. जस्ट टेक अ ग्लांस, ऊपर का ग्लांस लो. नहीं समझ में आता है, लीव इट, प्रैक्टिस क्वेश्चंस. ओके, नेक्स्ट, गैल्वेनोमीटर से हमको एमीटर बनाना है. ओके, आई टोल्ड दिस बिकॉज दैट यू डोंट गेट कंफ्यूज्ड. ओके, वोल्टमीटर जब भी बनाना है गैल्वेनोमीटर से जस्ट अटैच अ सीरीज रेजिस्टेंस. ओके, अच्छा, एमीटर से बनाना है तो एमीटर हम लगाते हैं. जैसे लेट्स से देयर इज अ रेजिस्टेंस लाइक दिस. ओके, एमीटर हम सर्किट में सीरीज में लगा देते हैं लाइक दिस. ओके, अब एमीटर को क्या देना होता है? करंट रीडिंग. इट शुड गिव करंट रीडिंग. ओके, दैट मीन्स एवरी करंट, ऑल करंट शुड पास थ्रू एमीटर. सारा करंट एमीटर से पास हो जाए. ओके, if all the current is passed through the emitter, then what we can do is make this emitter's resistance very low. इसका resistance बहुत कम करना है. Okay, इसका resistance बहुत कम करना है. So if you attach some resistance in series ना, the resistance is add, okay, directly. So resistance will increase. So series में ना add करते हो, what we will do, we will attach something to this galvanometer in parallel. Okay, पैरेलल में हम एक शंट रेजिस्टेंस लगाएंगे. ओके, which will, on adding with the galvanometer's resistance, increase its decrease its total resistance. Okay, total resistance को वो decrease कर देगा. And this resistance will be very low. Okay, चलो, we will now go to the question. Time is so much elapsed in this one. Question is telling the galvanometer 50 ohm resistance has 25 divisions, blah 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 blah, everything is there. A current of 4 into 10 to the power 10 minus 4 ampere gives a deflection of 1 division. To convert this galvanometer into voltmeter having a range of 25 volt, it should be connected with a resistor. So first of all, this galvanometer is converted into voltmeter. That means we are adding series high resistance. Okay, now it is telling galvanometer of 50 ohm. The reading of galvanometer is 50 ohm. It is having a 50 ohm. Let's say this is galvanometer. This is the resistor. It is 50 ohms. Okay. Of course, this whole makes what? Voltmeter, and it is connected in parallel to something. Now, no current should pass through it, first of all, or very less current should pass through it. ऐसा करते हैं. Current of 4 into 10 to the power minus 4 ampere gives a deflection of 1 division. So there are 25 divisions now. So range क्या होगा? 4 into 10 to the power minus 4 amperes into 25 division. That means this much current can pass through the maximum current can pass through the galvanometer. Okay. Now we want this setup or this voltmeter to be handling how many volts? 25 volts maximum. Okay, 25 volts maximum. So current we have, resistance we can multiply. Resistance is galvanometer resistance plus this series resistance. This is I, this is R, and this should be equal to 25 volts, which is the reading of this voltmeter, right? RG is how much? 50. Now from here easily you can find 20 R, this R. Okay, 25 cancelled out. I'm writing it here with the different color. So it is 4 into 10 to the power minus 4 into 50 plus R is equal to 1. So R क्या होगा यहाँ से equal? R will be equal to 1 by 4 into 10 to the power 4 minus 50. Minus 50. Okay, calculation कर लेना. Answer will be 2450. Not this one. Sorry, this is shunt na. Not this one. Fourth option. Series वाला. चलो next. Acha, this is simple. I'm not doing this one. Okay. When you put this ball inside na, it will have a upthrust. ऊपर upthrust लगेगा. So mg minus upthrust force you can easily calculate, right? So this will be the increase in the force of this pen. This is basically on a weighing machine. एक weighing machine पर रखा है ये, right? You can find the change in the weighing scale when you put this rod inside it by finding net force, net upthrust on this ball. Okay, that will be the change. Next. Okay, this question I'll do quickly. These all are which gates? Type in the chat. कौन सा gates हैं? Which are these gates? These gates are called this is AND gate ना. This is AND gate. 2 input AND gate. Okay, अगर इसमें आगे डॉट लगा दो तो ये NAND बन जाता है, right? It is now NAND, which is NOR plus AND. Simple. Not plus or, not NOR plus or. Sorry, written by mistake. Okay. So AND का क्या होता है? It is, where it gone? Okay, so AND का क्या होता है? It is A into B, A dot B, and when it is done not, then ऊपर A लग जाता है. Now we'll go to the question. A, B, these are the inputs. Whenever you have these questions, these type of questions, just assume inputs as A, B. So A जा रहा है यहाँ, B जा रहा है यहाँ, A here, B here. It will be A dot B bar. Okay. Now A is going here and A dot B bar is going here. Again, it will be NANDed. So A dot B bar a bar, right? Similarly here also B dot A dot B pe bar पे बार. Okay. Now these two inputs are going here directly like this, like this, like this. Okay. So ये क्या हो जाएंगे? Finally they will be a dot b पे बार dot b dot a dot b पे बार. Okay, what I have done? I have just taken the multiplication of these two and it is NAND, so I'll put a big bar here. अब इसको solve करना है, that's it. Then you'll get the answer. Sir, that is the problem, huh? देखो, how will solve it? Start from this one. You can write it as a dot. This is a dot b bar. So you can write it a plus b, and you will separate the bars, right? And there is one external bar here. Dot. Similarly, you can write for this also. B dot a plus b pe bar, and there is a big bar, right? And a whole bar. Whole bar also we can separate. Kaise? I'm writing one more step. I will attach here plus and the bar will come here. Double bar हो जाएगा. B dot A plus B bar. Okay. So this double bar cancels itself. Okay. Now you can solve it easily. You can take A plus B bar common. A bar plus B bar common. You will get A plus B. Okay. This is the common expression for XOR gate. कैसे करेंगे? अगर और solve करना है, if you want to solve it more, just multiply this with this, then this with this. You will get A B bar plus A bar B. Okay, this is XOR gate. XOR gate का output क्या होता है? XOR gate का output होता है 0 1 1 0, right? 0 0 0 1 1 0 1 1. A B, and this is output. This is the table for XOR gate. Now you can select the options. Okay, this was the concept here. Option, I think third or fourth, whichever is correct. I don't know the option which is correct. Okay, so you can do this one. Next one, I'll not do this one. This is not that much important. Okay, this one. This is a good question, right? In this question, it is telling this a uniform sphere of mass m and radius capital R. Okay, it is talking about this inside sphere. Is surrounded by a concentric spherical shell, and this is a shell of same mass but radius 2r. So the radius of this shell is double of the radius of the inner sphere, that is 2r. Okay. Now it is telling a point mass m is kept at a distance x. So there is a point mass here, see this one, which is at a distance x from the center in the region bounded by the spheres as shown in the figure. The net gravitational force on the point masses. Okay, so why this question is good is, tell me in the chat, force due to outer shell on mass m. Okay, tell me, इस outer shell की वजह से, due to this outer shell, what will be the force on this small mass m, which is inside this shell? Gravitational force, of course. क्या होगा? Tell me in the chat quickly. Don't sleep. You can sleep after the class. Nahari, Lakshmikant. Lakshmikant, you know, one book is there, Indian Polity. Lakshmikant, very famous book for politics. Kavita, Jagan. What will be the force due to outer shell on mass m? Answers came. Okay, Kavita is right. One कैसे होगा? How it is one? अरे, have you forget gravitation? So if there is a shell, spherical shell, and there is a mass at the center, let's say, okay, so the force will be how? This small particle on this of this shell will apply force somewhat like this, then this particle will apply some force somewhat like this, and there will be force from each side, and it will be absolutely balanced. Okay, gravitation potential inside the sphere is zero na, so it will be absolutely not zero, sorry, I told you wrong, not zero, absolutely balanced. Okay, so force will be absolutely balanced, that means force on this mass will be zero. Now there was one second case also. If you take this mass from center and if you put it anywhere, so it will adjust in such a way that the force due to the shell on this mass will again be zero. So force on M due to outer shell, irrespective of its position inside the cell, it is always zero. Remember this thing. Shell के अंदर mass कहीं पे भी रखो, gravitational force will be zero. क्योंकि let's say if I take this particle, अगर यहाँ से force लग रहा है like this, see distance is less, so force will be more. Okay, अगर इस portion से force लग रहा है, तो इस portion का opposite कितना portion आ रहा है? See this much portion. So ये portion अगर distance ज़्यादा भी है, distance is more also, but portion is more, particles are more, so they will apply equal force. Okay, so बाहर वाला shell की वजह से on this mass there will be no force. So force will be only due to the inner shell. Now it became the case. What case? There is a sphere having some mass, capital M, and there is a mass, small m, which is at a distance of x. ये question बन गया, right? So force will be simple, g m1 m2 by r square, g m1 m2 by x square, which is option first. Have you got this concept? ये समझ में आया? Okay, so there was a little concept that I want to remind you. The gravitational force inside a body which is inside the spherical shell is zero. Chalo. This one is simple, huh? Dekho, question is telling which of the following have maximum percentage of total kinetic energy in rotational form. So the total, if it is doing pure rolling, what it is telling? While pure rolling क्या होता है? जितना घूम रहा है उतना चल रहा है. Okay, how much it is rotating, it is moving that much. That is V is equal to omega r. This is the condition for pure rolling. So यहाँ पे दो energies आता है, दो kinetic energies आता है. One is called rotational kinetic energy, plus another is called translational kinetic energy. Two kinetic energies are there. Okay, formula भी देखते हैं. So kinetic energy will be equal to I omega square. I is what? I is moment of inertia plus half m v square. Right? I think this is simple. ये simple है. Okay, चलो अब ये आ गया है. Now it is telling that kinetic energy ऐसा out of these four, which is having its maximum kinetic energy in the form of rotational energy. Means let's say if kinetic energy कुछ है, there is some kinetic energy. So in which of these four figures the rotational kinetic energy will be occupying most of the kinetic energy? Okay, so इसका बात कर रहा है. Okay, let us assume velocity is constant. Okay, so half I omega square, omega is constant. Okay, so I will be variable. Okay, जिसका I moment of inertia ज़्यादा होगा, that will have maximum rotational energy. So moment of inertia of disk, if you forgot, I'll just write here. तो क्या होता था? mr square by 2. Second is sphere ना. स्पीयर का 2/5 mr², और थर्ड इज रिंग। रिंग का सिंपल होता था, वेरी सिंपल, mr²। हॉलो स्पीयर, हॉलो स्पीयर का क्या होता था? टेल मी इन द चैट, लेट्स चेक योर नॉलेज। व्हाट वाज द मोमेंट ऑफ इनर्शिया फॉर हॉलो स्पीयर? चैट में बताओ। Oh my god, so many questions we have to do. How we can complete in this small duration? What is the moment of inertia of hollow sphere? Tell me in the chat. Hmm? Googling it? Are you searching on internet? Good. Alish Haryani told the answer. Huh? What you people are doing? It is 2/3 mr². Okay. Okay. So which will be having more moment of inertia? Ring. So ring will be the answer. Chalo. Next. This is a simple question. We will not do this. What it is telling is there is a car which is having some path like this. It is moving with a velocity of how much? Let's say some velocity. Okay. Then it is telling that mass of this car is m. Okay. I'm not reading the question. I'm telling you the feel of the question. Mass of this car is m. Okay. Radius of the track is r. So this is a r radius track. Okay, and there is a static friction mu s. Okay, coefficient of static friction between the road and the tires of the car. The maximum speed of the car in circular motion is given by, so maximum speed, how much it will be? Just equate the centripetal force Fc with frictional force. Okay, frictional force is mu mg, centripetal force is m omega square r. So equate them, you will get the answer, right, for the maximum speed. Next. Okay, this plane mirror one we'll do. This is a good question. So a plane mirror hanging on a wall of a room. Let's say this is the room and this is the mirror. This is the wall. Okay, this is the mirror. Right. The opposite wall of height h at a distance d from the mirror, there is a person at distance d in front of the mirror. So there is a person here standing in front of the mirror at a distance of d. Right. Okay. Now the person want to see complete image on the opposite wall. Okay. This person want to see his complete image of opposite wall. अच्छा, इसके पीछे एक wall है. There is a wall behind it. Okay. ये wall है. This is it is having a height of h. And it is at a d distance of capital D. Okay. Now this person, this is the eyes. Okay, this eyes we can call. आंखें हैं ये, right? This person want to see complete image of opposite wall in the mirror. Then the minimum length of the mirror required. So let's say the mirror length is L. Okay, mirror का length क्या है? L है, और हमको इस length को बताना है if this wall is observed by this eyes fully, पूरी तरीके से दिख रहा है. Okay, so the simple idea behind this is, first of all, in case of these type of questions ना, you make the diagram. It makes it very simple. बहुत simple बन जाता है. अच्छा, this देखो इधर से light ray आएगा. This is the end of this wall. The light ray will go like this. ठीक है, at the edge, then it will go in the ice like this, and the bottom light ray of the wall will go like this, and it will go in the ice. Okay, now this is the condition when person can see full wall image, पूरा wall उसको दिख रहा है. This is the condition, है ना? So this L will be the length. Okay, now this image will be how? This ice को कैसा लगेगा? That image is formed backside somewhat here. So this is a virtual image, right? So उसको लगेगा wall is behind. Okay, this wall is again having a height of h, and कितना distance पीछे बनता है? Same distance as in front. Okay, that is capital T. Plane mirror है ना? This is a plane mirror. Okay, so D पीछे बनेगा. Now the basic idea is using mathematics here. Okay, mathematics का use करेंगे इस बड़े triangle में, right? This triangle is basically, this mirror is parallel to the wall. Okay, so parallel अगर line बनाए, then these two triangles are similar. Okay, same angles they will have, right? So we can write L by small d. Okay, this length by this length is equal to h by small d plus d. This full length by full length of the triangle, right? Now from here we can easily find क्या निकालना है? L निकालना है, right? Length of the mirror. So L will be dh by capital D plus small d. Okay, so which will be the answer? Second option. Next, this one I think you can do. So I'll tell you the concept here. There is a rocket. It is going upside. Okay, usually rockets are not like this. This is a prototype. Okay, so it is giving some airs from backside, right? So velocity of gases is given, and it is having a fuel of 1000 kilograms. Okay, this 1000 kilogram is consumed at the rate of 40 kilogram per second. 40 kilogram per second. इसका मतलब this much mass is consumed in 1 second. Okay, this is the rate of change of mass. So I can write it as dm by dt. Change of mass of this rocket with respect to time. Are fuel is burned now, so it will go out of the rocket. Correct. Now, अब क्या होगा? The thrust on the rocket we have to calculate. So when these gases go down, na, this rocket will have some thrust in upward direction. Okay. So we know force. Thrust is basically perpendicular force, huh? Acceleration. Okay. Acceleration, I will write dv by dt. But this dv is constant here. Change in velocity is zero, na? Velocity is constant. So acceleration is not changing. That means acceleration is constant here. But changing is mass. Mass is changing. So what I can write is F is equal to dm by dt into A. Okay. Now easily we can do, just put the value of dm by dt, that is 40. एक minute, had I made some mistake here? 20. Yeah, correct only. Yeah. Okay. So acceleration को dv by dt लिखते, but here the velocity is constant, right? So we will write v by dt, और dt हम dm के नीचे ले आए. So this will be velocity now. Okay. Change of momentum also we can call na force. So that same thing here it is. Okay. So dm by dt into velocity, that is 5 into 10 to the power 4. Solve it, we'll get the answer. Okay, chalo, we'll stop here. I'll launch the NPS poll and then we will end the class. If there are some doubts in JEE and NET, NEET, then you can just message me. I'm there in the group. So I'll just give you my own solution, or what I will do is we can discuss it in next class also. I'll spare some 10 or 15 minutes at the end of the class. If there are doubts, then you can ask me. Is this thing clear? समझ में आया? आज का क्लास थोड़ा कम इंटरेक्टिव हुआ because so many questions were there ना. I was so much tensed. How many questions I can do maximum? बोलो. Is everything clear? सब समझ में आया है? Doubts are not there. I am just launching the poll. Okay. Participate in the poll. Yeah, Karan Chauhan, thumbs up. JNB KLB. What is the meaning of KLB? Which place KLB? Karan? Yeah, all should complete the NPS. Kal Buragi, Kala Buragi. I am from MP, Madhya Pradesh, a city called Gwalior. I think you have heard about it. Gwalior ka Killa you have heard, I think. Jhansi ki Rani you have heard. It was the second most popular polluted city some days back, some months back. So many industries are here, no? That's why. After Delhi. Yeah, I worked little bit before Corona in JNB Hassan. Hassan, I was there. Then I came back at home due to this Corona. Yeah, Gautami, welcome. NPS is done. 82% of you have voted. कौन बचा है? Chalo, fine. So what we will do here, we will just end the poll. Okay, Pramod. We'll end this poll and we will meet in the next class. Okay, next class is important because we are going to start revision of laws of motion. Okay, chalo, bye bye and have a good day.